Hello everyone, welcome you all. Here I am going to discuss the thermal conductivity of a material K. Thermal conductivity is one of the basic property of a material which is concerned to the heat transfer. And I am going to discuss here what is that thermal conductivity, what are the parameters which will affect on that thermal conductivity, and also I am going to take the how it can be determined experimentally, and we'll take the some of the important materials and their thermal conductivities. Firstly, we'll take its definition. The thermal conductivity is the physical property of a material and is the ability of the material to conduct heat whenever the heat is transferring through a solid, and that solid material, how much it has the ability, how much it has the ability to conduct the heat, that we are going to measure in terms of a thermal conductivity. Okay, that is the thermal conductivity of the particular material. And by the formula also we are going to take by the heat transfer equation that thermal conductivity. Thermal conductivity is the rate of heat transfer through a unit thickness of the material per unit area per unit temperature difference. It is denoted by the uh, symbol K, and this can be given by the Fourier law of conduction. By the Fourier law, we can have this equation. The Fourier law, by the Fourier law, we can give the heat transfer. That that is the Fourier law states that the rate of heat transfer is directly proportional to the area normal to the heat transfer and temperature gradient in that direction. And there the proportionality sign we have taken as the K. And this K is the thermal conductivity. Then we can take the K equal to, that is Q by A into T1 minus T2, this term, and into dx. And by that, this term we can have its unit. That is, watt is the unit of the heat transfer, and this is a meter, and area is meter square. Therefore, in the denominator 1 meter remains, and temperature difference is degree Celsius, or we can say watt per meter degree Kelvin. Because here the temperature either we can take in terms of the degree Celsius or in degree Kelvin, the temperature difference will be remain same, and that's why we can use the unit either watt per meter degree Celsius or watt per meter degree Kelvin, one and same. And one may get confused about this one, what to use, whether we have to convert that unit or not. But any one unit we can use that one, it will not matter in that equation of the conduction. And here a high value for thermal conductivity indicates that the material is good conductor of heat. It is conducting a better heat. And a low value indicates that material is a poor conductor of heat. Poor conductor of heat or a insulator we can call. Whenever in particular condition, if the heat transfer required is more, then we are going to use the good conductor of the heat. Okay, that is we can say that one higher conductivity of the material. And if the insulation is required, heat transfer is to be restricted, and there we are going to use a poor heat conductor or a insulator. And here is the one of the example we can say. Here the heat is transferring in this direction and through this material from the temperature T2 to the temperature T1, because the temperature T2 is higher than the T1, and where these two temperatures are at a distance of d here. And here the material through which the heat is transferring, that material is having the thermal conductivity K, and area A we are going to use here. Here one of the experimental setup, and where simple experimental setup to determine the thermal conductivity of a material. This is the experimental setup. Here the sample material is used to, for which the thermal conductivity is to be determined. For that, it is having the length L and surface area A, and the temperature at 1 surface is T1 and another surface T2, and its thermal conductivity K is need to determine. And for that, the electricity work, the electrical work, the heat is to be supplied, and from that heat is conducting through this material, and that is the heat transfer will be equal to the electrical heat supply what is there. Okay, as we know that how much quantity of the electricity or electrical work we can supply, and from that we can have the how much amount of the heat is to be supplied. And by knowing all these parameters, thermal conductivity can be given as L by L we know, area we know, temperature, both the temperatures we know, and temperature difference we can take, Q we can have. And from that, thermal conductivity of the material we can determine experimentally. For the simple configurations, we can determine experimentally. For complex configurations, we can determine by using the empirical correlations. And here, the thermal conductivity of some materials at room temperature we can have the material and thermal conductivity in terms of watt per meter degree Celsius. Diamond is having the highest thermal conductivity. Next comes silver, copper, gold, aluminum, iron, and mercury having next. The liquid metal is having the next one. And from that later onwards, all other metals having the lower thermal conductivity. That's glass, brick, water, human skin, wood, oak, helium, gas, soft rubber, glass fiber, air as a gas, urethane, rigid foam. These are having the lowest thermal conductivities. Air is having the lowest thermal conductivity because as we know that one, here the thermal conductivity in that taking place, thermal conduction is taking place through the solids where the molecules are closely packed. And through the molecule, one molecule to the another molecule, heat is transferring in the thermal conduction. But in the gases, it is not possible. The molecules are not in contact. Those are away from each other. And there the conduction heat will be not taking place. And at a lowest rate, the heat transfer is taking place. And therefore, gas is having the lowest ability to transfer the heat by conduction. Then the thermal conductivity varies with the parameter temperature. As the temperature is changing, the thermal conductivity also changes. But it is not varies with respect to pressure. It is not varies with respect to pressure and varies with respect to temperature. And in most of the practical cases, the variation with respect to temperature also we are not going to consider. The constant thermal conductivity of the material we are going to take at the lower temperature. At a higher temperature, the variation we need to consider. This is about the thermal conductivity of a material, what we can use as a important property for the heat transfer. And I am going to take some other the topics on this heat transfer in further sessions. Thanks for watching. If you like, share, subscribe, and comment.